This is a lesson that I told you I was going to record about the 3 problems that I didn't get to do in class related to solving systems of linear equations by using matrices, by using the Gauss-Jordan elimination with back substitution. So I did section 6.1. You can see the problems that we had already worked in class. And so 6.2 is basically what I didn't get to do. It's 3 problems. It's the same as this last problem I did on from 6.1. This really lengthy one where we solve for x, y, and z that you have on the notes on doc sharing already, this document. And tonight, after I finish working on this entire presentation, I'm going to update that document called section 6.1 and 6.2. It's going to be updated having the problems that we're going to see in this video. So it's the same process, except that the kind of answer is what's different. In this problem, we got a unique solution. X equals 0, y equals 10, z equals 13. Well, in these ones that are coming up in 6.2, the solutions, one's going to have no solution, and the other one is going to have infinitely many solutions, or many solutions, basically. And the other one, the last one over here, it's going to be, it's one that has infinitely many solutions, but it's kind of special, a little bit different from the other two in this section. So I'm going to start with this one. So it says use Gaussian elimination to find a complete solution to the following system of equations or show that none exists. So we're going to do it the way that we were doing the other ones. So I'm going to set up my matrix. 9, 4, 1, 29, 13, 3, 1, 3, negative 5, the line, 10, negative 6, and 8. So our first, if you remember, like, what's our goal? What are we trying to accomplish? Well, we're trying to have 1, 0, 0. And I told you that this place can be, or this entry can be any number. Then you want to have a 1 here, a 0 under this 1. Then over here in the next column, this entry can be whatever number, this one as well, but then you want to have a 1 here. So we want to have this diagonal of 1s. Just reminding you what is it that we're trying to do. And I told you we're going to work by columns. Until you're finished with one column, you can move on to the next one. So we're going to first here interchange row 1 and row 3. Why? Because, well, I have a 1. I want to have a 1 in the first column, and there is already a 1 in the row number 3. So why not just simply swapping or interchanging these two? And that's what we're going to do. So in the next step, I'm going to put 1, 3, negative 5, 8. So you see how all the numbers in row 3 went to row 1. So all the ones that were in row 1 are going to go to row 3. 9, 29, 1, and 10. And the one in the middle, row 2, that one's not changing right now at all. That one we're just going to keep where it is. So I already made a 1 here. The next thing that I want to do is make the 4 that is under that 1, make it into a 0. So we need to come up with a rule to make or to convert that 4 into a 0. So we're going to change row 2 by multiplying negative 4 times every number in row 1, and then we're going to add the values in row 2. So why I chose negative 4? Because negative 4 times the one that I circle, it's negative 4. And that negative 4 plus 4, it's going to give me the 0 that I want underneath that 1. So I'm going to right here, I'm going to copy row 1, 1, 3, negative 5, and 8. I'm going to put a parenthesis, and we're saying that every number in row 1, we're going to multiply times negative 4. Whatever we get, we're going to be adding that to, we're going to be adding that to row 2. So, let's do first, I guess, the multiplication of all this ones. Negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12. Negative 4 times negative 5, positive 20. Negative 4 times 8, negative 32. So right here, what we were doing is distributing. Multiplying this one times each of these numbers. And so you see the answers under the line, below the line. So now this, we're going to add them to every number that is in row 2. So I'm going to do plus, and I'm going to copy here all the corresponding entries to each of these ones, but in row 2. So my new final row 2 is going to be negative 4 plus 4 is 0, negative 12 plus 13, 1, 20 plus 3, 23. That 3, let me rewrite it. 23. Negative 32 plus a negative 6, negative 38. So, what I'm going to do now is rewrite the first row in the matrix, and then the second row, remember that now it's going to be affected, or is going to be changed. And you know what, let me do this one in red, and so that's going to help you see that row 2 change to those values. Row 3, right now we're not changing at all. So now you need to think, what's the next thing that we have to do? Well, now we have to make a 0 where you see this 9 in the first column. So then row 3, now it's going to change. How? By you multiply negative 9 times every number in row 1, and then we're going to be adding those answers to row 3, to every number in row 3. Why? Because negative 9, I'm trying to make this one a 0, right? But negative 9 times the one that you see on the top of the first column is going to be negative 9, and then if you add negative 9 plus that 9, that's going to be 0. So I'm going to copy all the numbers in row 1. 1, 3, negative 5, 8. And I'm going to multiply all these ones times negative 9. So I'm going to put a line here, draw a line. Negative 9 times 1, negative 9. Negative 9 times 3, negative 27. Negative 9 times negative 5, positive 45. And then negative 9 times positive 8, negative 72. So the rule says, okay, negative 9 times every number in row 1. That's what we just did. Then it says add those answers to every number in row 3. So I'm going to copy all the numbers here in row 3. And then we start adding them. So this is going to be 0. This is going to be 2. This is going to be 46, I'm sorry. And this one's going to be negative 62. And so, and I've been forgetting that I'm supposed to put them with a different color so that you see when we write them again in the new matrix. So here, first row, it's not changing, so we're going to rewrite it again. second row, right now, it's not where what we changed. We changed row 3. So 0, 2, 46, negative 62. So now what we want to do is, if you go back to what is it that we're trying to do, is 1, 0, 0 in the first column, second column, a 1 in the middle, and then a 0 underneath that 1. And if you observe, we already have a 1 in the second column in the middle. Not that we try to make it, but I mean it's already there. So now the next thing is make the 2 underneath that 1 to be a 0. So how are you going to make it? Well, now you're going to do again row 3. You're going to do negative 2 times row 2 plus row 3. Why? Because negative 2 times the 1 that is on top of that 2, negative 2 times 1 is negative 2. You add it to a positive 2, that's going to give you 0. So let me copy every number in row 2. We multiply this times negative 2. So I draw a line. Negative 2 times 0, 0. Negative 2 times 1, negative 2. Negative 2 times 23, negative 46. Negative 2 times negative 38 is going to be 76. Positive 76. So we did already this one, and this one. And now I'm going to add to these numbers every value that we have in row 3. Let me make this negative better. Okay. So 0 plus 0 is going to be 0. Negative 2 plus 2 is 0. Negative 46 plus 46 is 0. And this one, negative 76 minus 62 is going to be sorry, positive 14. So the matrix is going to look like, and I keep on forgetting, making these ones in red. Sorry. 1, 3, negative 5, 8, 0, 1, 23, negative 38, and then here we have 0, 0, 0, and a 14. So I'm going to stop here, and I'm not even going to try to make the 0 that you see in the third column. Technically we should work it out to make it a 1, right? Because we want our diagonal of 1s here. But we're not going to do it because this is a special case. I told you this problems that I was missing were special cases where either there's no solution or there are many solutions, infinitely many solutions. Well, in the last row, when you have this, that all the numbers before the line, the blue line, are zeros, and the number after the line is whichever number you wanted it to be, like positive, negative, fraction, whatever. But before there are zeros and then a number that is not 0, this is no solution. And that's what you have to do and write. That there is no solution for this problem. You need to stop working it out, and that's it. There's nothing else you can do. Okay. So moving on to the next problem. Okay, let's see what kind of case this is going to be. So 3, 12, negative 13, negative 1, 2, 9, negative 10, negative 3, a 1, a 3, negative 3, and 2. So first thing that we want to do, we would like this 3 to be a 1. And if you see, there is already a 1 in that same column, but in row 3. So these two, we can interchange them just like we did in the other one. Interchange row 1 and row 3 from place. Row 2 is going to stay where it is. So 1, 3, negative 3, 2. The middle one, the row number 2, is going to stay the way that it is. But row 1 is going to go to row 3. To where it used to be row 3. Next thing that we want to do is this number we want it to be a 0. So what could we do? Well, row 2 is going to be negative 2 times every number in row 1 plus every number in row 2. So we're going to do the same thing that we did before. Copy all the numbers in row 1. 1, 3, negative 3, and 2. We're going to multiply all these numbers times negative 2. So negative 2 times 1, negative 2. Negative 2 times 3, negative 6. Negative 2 times negative 3, positive 6. And negative 2 times 2, it's a negative 4. Plus every number in row 2. So plus 2, plus 9, negative 10, and negative 3. And then you just add them up. So this is going to be 0, 3, negative 4, negative 7. 0, 3, negative 4, negative 7. So now we rewrite here 1, 3, negative 3, 2. Let me make this line better here at the end. And then in row 2, 0, 3, negative 4, negative 7. 3, 12, negative 13, negative 1. So the next thing we're going to do is make this one a 0. So row 3, it's going to change by you doing negative 3 times every number that is in row 1 because there is a 1 at the top. And then you add that to row 3. So row 1 is 1, 3, negative 3, and 2 again. So we're going to multiply these numbers by negative 3. So, sorry, I forgot to draw the line. Negative 3 times 1, negative 3. Negative 3 times positive 3, negative 9. Negative 3 times a negative 3, positive 9. And negative 3 times a positive 2, negative 6. Then, to each of these numbers, we're going to be adding the values in row 3. So we write them here underneath this one. So this is 0. This is going to be positive 3. This is going to be 10, 11, 12, 13, negative 4. And this is going to be negative 7. Let me write them in red, and then we rewrite again. First row stays the same. Second row stays the same. And now the third row was the one that was changing. 0, 3, negative 4, negative 7. So now what do we want to do? Well, we want to make this one to be a 1, right? That entry. So row 3, to make 1s, you're going to multiply times the reciprocal of that number. So you're going to multiply every number in row 3 by 1/3. So 0, 3, negative 4, negative 7 gets multiplied times 1/3. 1/3 times 0 is 0, 1/3 times 3 is 1, 1/3 times negative 4 is negative 4/3, and 1/3 times negative 7 is negative 7/3. So then we rewrite the matrix. So row, and I'm sorry that I put here, I'm just seeing that I put row 3 and it was row 2. Sorry, I meant to put in here row 2. Sorry. So this is going to be 0, 1, negative 4 over 3, negative 7 over 3. This one right now it's the same. Then we're going to, now we want to make this 3 underneath this one to be a 0. So row 3, it's going to change by multiplying negative 3 times the one that you see on top of the 3, and that one is located in row 2. So times every number in row 2, and then you add it to row 3. So we're going to copy all the numbers in row 2. And so I'm going to do negative 3 times each of these numbers. Negative 3 times 0, 0. Negative 3 times 1 is negative 3. Negative 3 times negative 4 over 3, it's going to be 4. Negative 3 times negative 7 over 3 is going to be positive 7. Then we're going to be adding all the numbers in row 3. So plus 0, plus 3, negative 4, plus negative 7. And we draw the line. So this is going to be 0 plus 0, 0, negative 3 plus 3, 0, 4 plus a negative 4 is 0, and 7 plus a negative 7 is 0. So the matrix is going to look like 1, 3, negative 3, 2, I think it's a 2, I cannot see, yeah, it's a 2. Then you have 0, 1, negative 4 over 3, negative 7 over 3, and then this one, which are all zeros by the way, you're gonna place them in the last row. So this is the other special case. When all the last row has all zeros everywhere, okay, it's not like no solution. Let's look at no solution for a little bit. No solution in the last row has 3 zeros and then a number to the right side of the line, whichever number it is, but it's not a 0, definitely. And this one has all numbers being 0 in the last row also. This is going to be infinitely many solutions. Now, if it is this kind of problem, you cannot stop and say, like in no solution, just say no solution and that's it. You cannot just say, this is infinitely many solutions and that's it. You need to write equations down with what you have here, with what you have in the matrix. So for example, this one, this one is going to be an equation. You know that this column is x, this column is y, this column is z. The line represents your equal sign, and then you have your numbers over here on this side. So you have 1x plus 3y minus 3z equals 2. That's the first equation. Second equation, it's going to be there's no x, there's just 1y minus 3z or equals negative 7 over 3, or negative 7/3. And then the last row, it's a bunch of zeros, so you don't have to put 0x plus 0y plus 0, like there's no need for you to do that. But what you do have to do here is always take the smallest from right after setting these two equations, because in infinitely many solutions there's only 2 equations you're going to be able to set up, because the third row is going to be nothing technically. you're gonna get the smaller equation out of this two, always. And you're gonna solve for the variable that is not repeated. If you look at what I mean, like what variable is repeated? Z, and Z, it's a variable that is repeated in both equations. It's a common letter to both, a common variable. Well, take the second equation and solve for the variable that is not repeated, that is not the one repeated in both. That means solve for the y. So how do I solve for y? Well, all you have to do is move this term to the other side. So if it is minus 4 over 3z, do plus 4 over 3z plus 4 over 3z on both sides. And then you're going to get y equals, I'm going to write first 4 over 3z minus 7 over 3z. And these two are going to cancel. So this is one of your answers, this equation. But we're not done yet. Now you're going to use this equation to plug in where? Into the equation, into the first one that has three variables. I'm going to do here x plus 3. I don't want to confuse you because it looks too close. But as a second step, now you're going to do x plus 3y minus 3z equals 2. So all this, that is the value of y, is going to go into this y. So you're going to do x plus 3 parenthesis 4 over 3z minus 7 over 3z. And then minus 3z that was already there equals 2. So you're going to distribute 3 times 4 over 3. The 3's are going to cancel. And you're going to bring down plus 4z. Or put it in the calculator. 3 times 4 over 3 and you're going to get 4. Then 3 times negative 7 over 3. The 3's again are going to cancel. But this time you have a minus at the front of the 7. So make sure you put minus 7z. Or again, just put in the calculator 3 times a negative 7 over 3 and you're going to get negative 7 as the answer. Then you bring down the negative 3z. The equals 2. And then if there are any like terms that you can combine them. Like this, this 3 actually. So you have, let me see, let me take a closer look at this. I see a careless mistake that I did. I was looking at something was being a little weird. This negative 7 over 3 does not have a z, and I put a z by mistake. So this negative 7 over 3z should not be here. This one should not be here, so this is not a like term with the ones that have z's, only those two. So x, 4z minus 3z is plus 1z minus 7 equals 2. So now, again, there's two variables, x and z, right? And there's a constant. First thing you're going to do, move the constant to the other side. So x plus z equals 9. This you're going to cancel. So from the two variables that you have, you're going to have to solve for one of them. Solve for the one that was not the letter that was in common to the two prior equations, to the two previous equations, which is the z. We had already said that z was repeated in both. So you have to solve here for the one that is not the one that was repeated. So you're going to solve for x. That means z is going to have to go to the other side. How? By subtracting in this case. So you're going to have x equals 9 minus z, or negative z plus 9, however you want to write it down. And these two cancel each other. So you're going to write the final answer for this one. That is a little bit different from having a unique solution or no solution, your answer is going to look like put a little bracket like this, then put a parenthesis, and first you're going to copy the equation that is solved for y. No, I'm sorry, the one that is solved for x. So this one, 9 minus z. This represents your x variable. Then y, it's 4 over 3z. That z didn't look good. 4 over 3z minus 7 over 3. Comma, now, you see how we never solve for z because the z was repeated? Well, that variable that is repeated, all you're going to do is write it as comma z. And then a bracket. And let me write this a little bit better. And that's it. And that's how you write your answers, besides the fact of saying that you have infinitely many solutions. So for this, like on a paper test, if you only say infinitely many solutions but you do not write the equations, then and solve for whatever you need to solve except for the variable that is repeated in both equations that you're going to end up with, then that's going to give you partial credit. So on the paper test that you're going to do of chapter 5 and 6, you need to make sure that if it is this kind of problem with that answer, then you need to make sure you write it like this. Okay. The next one, you need to memorize this. It's very, very important because there's no other way to figure out this. A system of linear equations containing more variables than equations. It's said to have infinitely many solutions. Okay, I'm gonna let's read it again. A system of linear equations containing more variables than equations is said to have infinitely many solutions. So automatically, every time you see that there's more variables than equations, the answer is going to be infinitely many solutions. We can see on this one that we have x, y, and z, 3 variables, and yet we only have 2 equations. So automatically know that's going to be the kind of answer. But does that save you working it out? No, you still have to work it out, even with 2 equations only. So we're going to do the same drill. 8, 1, negative 1, 8, 9, 9, negative 8, and 9. So you have to think, what is it that I want to do first? Well, I want to have a 1 here, right? So how can we make a 1? Well, I'm going to do row 1. I'm going to multiply it times the reciprocal of 8, which is 1 over 8. So I'm going to copy every number in row 1, and I'm going to multiply it times 1 over 8. So 1/8 times 8, 1. 1/8 times 1, 1/8. 1/8 times negative 1, negative 1 over 8. 1/8 times 8 is going to be a 1. So we write down the new matrix, where these are going to be my new values for row 1. And this is an 8. Sorry. 1, 1 over 8, negative 1 over 8, and then a 1 over here. And you know the line is right here. Number 9, 9, negative 8, and 9 goes in the same place. Then we have to make this 9 to be a 0. Row 2, we're going to multiply negative 9 times row 1, and then we're going to add it, sorry, not to 9. I mean, we are going to do that, right? But I was thinking just on the number. then we're going to add it to row 2. So we copy all the numbers in row 1. 1 over 8, negative 1 over 8, a 1. We multiply all this times negative 9. So negative 9 times 1, negative 9. Negative 9 times 1/8, negative 9 over 8. Negative 9 times a negative 1 over 8, positive 9 over 8. Negative 9 times 1, negative 9. Then we're going to add all these values to every number in row 2. So we rewrite them here. So negative 9 plus 9 is 0. Negative 9/8 plus 9. Let me see, negative 9/8 plus 9 is 63 over 8. You can use the calculator. I already did them ahead of time to save time right now. And then 9/8 plus a negative 8 is negative 55 over 8. Then negative 9 plus 9 is 0. And this is a negative 55. So we rewrite 1 over 8, negative 1 over 8, the 1, and then this is 0, 63 over 8, negative 55 over 8, and 0. And so now our goal is to make this one to be a 1. So row 3 again. To make it a 1, multiply that number by its reciprocal. So, sorry. The reciprocal of 63 over 8 would be 8 over 63 times row 2. So I'm going to copy all the numbers from row 2. And we're going to multiply them times 8 over 63. So this is 8 over 63 times 0, 0. 8 over 63 times 63 over 8, it's a 1. 8 over 63 times negative 55 over 8 is going to be negative 55 over 63. And then positive 8 over 63 times 0 is going to be 0. That was an ugly matrix. So now we set it up again. 1, 1/8, negative 1/8, and 1. And this one, which are going to be the last row, are going to go here. 0, 1, negative 55 over 63, 0. So here, remember that we want to do a diagonal of 1, where the diagonal is already here. 1, 1. There's no third row to do another 1 here, right? And that would complete my diagonal. So I'm gonna need to stop here. That's it. I cannot do more because I don't have the third row to say I'm gonna make this one a 0. I'm gonna make underneath the first 0, I'm gonna make another 0. Underneath the 1, I'm gonna make a 0 here. Like, we cannot just continue. We're gonna need to stop with this special case. So we already knew, because we're gonna memorize the concept or the fact that every time we have more letters or more variables than equations, it's gonna be infinitely many solutions. It's just we have to go through with it, even if we know that, pretending like we don't know, trying to make the first number a 1, then the number below it a 0, in the next column make the middle number a 1, but then we stop because there's nothing else we can do. There's not a third row to continue. So what are you going to do? Write equations. This is going to be x, because you know these are your x's. This is going to be your y. This is going to be your z, and this is going to be your equal. So x plus 1/8 y minus 1/8 z equals a 1. Second equation has no x, has just one y, minus 55 over 63 z equals 0. So remember what I told you. The variable that is repeated, that's the one that you're never going to solve for. And you have to start by the smaller equation, solving it for y, not for z, obviously. So I'm going to go here. Y minus 55z equals 0. So 55 over 63. We're going to be sending this term to the other side. How? By adding it to both sides. So plus 55 over 63z. This to cancel out each other. Y is equals to 55 over 63z. So that's my first equation solved for y. That's the value of y represented with that equation. So from here, I'm going to use this to replace where? Into the first equation, the longer one, the one that has the 3 variables. So into x plus 1 over 8 y minus 1 over 8 z equals 1. We're going to put it in here, into the y. So x plus 1/8 times 55 over 63z minus 1 over 8z equals 1. So this is going to be, when you can multiply these two fractions in the calculator, you can do it by hand, the top times the top, the bottom times the bottom, however you want to do it. The thing is, after you multiply them both, you're going to get 55 over 504 z minus 1/8 z equals 1. So combine like terms, these two. You can do in the calculator 55 over 504 minus 1 over 8. Just make sure you use parentheses around the two fractions. If not, you may get something different. So x minus 1 over 63z is what you're going to get out of combining those two, equals 1. So solve for x, don't solve for z. Remember, we're going to solve for the variable that was not the one that was repeated. So now we're going to do plus 1 over 63z to pass that term to the other side. Oops. Here. So you get x equals 1 over 63z. And then you write the answer. So how is the answer going to look like? Remember, you're going to write it as bracket, parenthesis. First, the x value. What's the x value? 1 over 63z, the equation that represents the x value. Then the y value, it's 55 over 63z. And then at the end, the variable that was repeated, which is the z. And I feel that I missed something. Yes, here, sorry, I missed to bring down the 1. There was a 1, right? And these are not like terms, and I don't know why I forgot and ignored the 1. So here, we're also going to be putting made a mess in here. The y was after. So 1 over 63z plus 1, comma, and then the y was 55 over 63z, comma, z. Sorry about the little confusion there at the end, that I forgot the one on the X value. And that's basically the 3 problems that I meant to do in section 6.2, the special cases. Okay, so that is it. Hope you understood the process, and this PDF file will be in doc sharing, updated. So look for 6.1 and 6.2 together in the same file, and now it will be updated. And I'm gonna send you the link right now. Once I create the video and I upload it to YouTube, I'm gonna send you the link so that you can watch it. Thanks.